Okay, so imagine taking a basic run-of-the-mill pocket calculator and trying to turn it into a modern smartphone. Crazy, right? Well, that is exactly the kind of massive leap we're looking at in today's explainer. We're going to explore how blockchain architecture evolved from Bitcoin's single-purpose ledger into Ethereum's programmable world computer.
It really begs a massive question. Like, what if the blockchain could do so much more than just manage money? We're jumping straight into the original Ethereum whitepaper today to figure that out. We'll be tracing this truly brilliant evolution from Satoshi Nakamoto's original Bitcoin design all the way to Vitalik Buterin's vision for a general-purpose platform. Now, to really appreciate Ethereum, we kind of have to look back for a second. Believe it or not, digital cash was a graveyard of failed ideas for almost 3 decades. You had the eCash protocols of the 1980s, Wei Dai's B-Money back in '98. But these early concepts kept stumbling. Why? Because they always ended up relying on some centralized middleman or a trusted computing backend. It wasn't until 2009 that Satoshi Nakamoto finally, absolutely cracked the code. And here's the thing, Satoshi's real breakthrough, it wasn't actually the digital currency itself. It was the proof-of-work consensus. Basically, this created a highly effective first-to-file system that elegantly solved the infamous double spending problem. Think about it. If someone tries to send the exact same Bitcoin to 2 different people at the exact same time, only the transaction that the network confirms first will actually process. Boom. No more need for a central bank. So, mathematically speaking, under the hood, Bitcoin operates as what's called a state transition system. It sounds complex, but it's really just taking a current state of ownership, applying a transaction to it, and then the protocol spits out a new state prime, which is just the end result of that transaction. It's a rigid, super secure gauntlet. Bitcoin processes these transactions by running some very strict checks. It looks to see if the UTXO, that's the unspent transaction output, actually exists. It verifies the cryptographic signature, and it strictly enforces the conservation of value. And it's entirely binary, guys. It either outputs a newly updated state or it just throws an outright error. There is zero middle ground here. Once validated, these transactions are bundled up by miners into blocks, roughly every 10 minutes or so. And because each block cryptographically hashes and persistently points back to the one immediately before it, it creates this unbreakable, immutable timeline. It literally stretches all the way back to the very first Genesis block. Now, a lot of this immense security is powered by something called a Merkle tree structure. It's so cool. Basically, if any malicious user tries to tweak even a single tiny transaction way down at the bottom of the tree, that error instantly cascades upward. It completely alters the root hash at the top, which immediately invalidates the entire block for the rest of the network. It's just elegantly tamper-proof. Because this consensus engine was so incredibly secure, developers quickly woke up and realized, hey, this can be used for way more than just money. And that sparked a massive wave of early experimental applications built right on top of Bitcoin's infrastructure. We saw things like Namecoin acting as a decentralized domain registry, colored coins representing custom digital assets, and even metacoins, which tried to run arbitrary overlay protocols just using standard Bitcoin transactions for storage. But those early innovators hit a massive architectural brick wall. You see, Bitcoin's built-in scripting language was just incredibly restrictive. It was value blind, meaning it couldn't give you fine-grained control over withdrawal amounts, and it completely lacked internal state memory. UTXOs are either spent or they're unspent. That's it. Developers desperately wanted to create complex, multi-stage financial contracts, but the base layer just flat out wouldn't let them. The absolute biggest roadblock, Bitcoin's script was not Turing complete. It intentionally left out the ability to run infinite loops, specifically so that malicious actors couldn't just freeze up the network forever. Now, that is absolutely brilliant for network security, for sure. But it is terrible if you're trying to code an advanced financial application directly onto its native layer. So, enter a young Vitalik Buterin. He recognized a fundamental truth. You cannot force a pocket calculator to run smartphone apps. It just won't work. So instead of trying to hack all these advanced features into Bitcoin, he envisioned an entirely new, generalized, foundational layer, a truly abstract platform where you could program literally anything. His vision was brilliantly simple, and it's perfectly captured in the white paper. It says, what Ethereum intends to provide is a blockchain with a built-in, fully-fledged Turing-complete programming language. No more complex, clunky meta protocols forced on top of a rigid structure. Just a raw blockchain that inherently understands whatever arbitrary logic you decide to feed into it. But to actually pull this off,
The underlying architecture had to change entirely. Ethereum completely abandoned Bitcoin's restrictive UTXOs and swapped them out for a highly flexible, account-based state transition system. By tracking balances and state directly inside user accounts, the math just becomes vastly more intuitive for programming and maintaining that multi-stage logic.
Under this new model, an account is its own self-contained environment. It holds its own persistent state, it has a nonce to prevent replay attacks, an ether balance, and okay, here is the real game changer. It can house its own self-executing smart contract code right alongside a dedicated storage space for its data.
What this does is create a first-class citizen dynamic. It basically grants Ethereum contracts an absolute superpower. Once you deploy it, the code acts exactly like a human user. A smart contract can read its own storage, it can route funds, and it can even autonomously spawn entirely new contracts, all without a single drop of human intervention. It's wild.
But wait, I know what you're thinking. How on earth do you prevent those infinite loops that terrified Bitcoin's creators, especially in a system that is fully Turing complete? Well, Ethereum solves this so elegantly by introducing the concept of gas. Basically, you set a starting limit, and you pay a tiny, fractional micro fee for every single computational step the code executes. If a bad piece of code goes into an infinite loop and the gas runs out, the program simply halts and all state changes revert back safely. So, the network stays completely protected while remaining fully programmable.
Armed with these robust tools, the entire landscape changes. I mean, we aren't just sending digital money back and forth anymore. We're deploying decentralized exchanges, autonomous identity systems, complex financial derivatives, and even entire sprawling companies run completely by code, all powered by just a few lines of logic on a global computer.
As we wrap up this explainer, I want to leave you with a bit of a provocative thought. If you suddenly had the power of an unstoppable, programmable world's computer right at your fingertips, what legacy systems in our society would you choose to decentralize? Think about how this foundational shift from a simple ledger to a programmable computer changes finance, governance, and honestly, trust itself. Keep exploring, and hey, thank you so much for diving into the source material with me today.